Hello, good morning. I welcome you all to School at 5. So this is something that I want to discuss with you. This is a topic that I want us to start in today's School at 5. So let's make sure that we join in. Thank you so much for joining me. Thank you so much for waking up at 05 so that we try to discuss some of these important questions that get to come in an exam. So I'm here to make this very simple. I want to make this very simple so that we are able to answer questions that come in an exam under this. So this is our physics. This is our physics where we are looking at simple machines. So this is physics. I want us to look at simple machines, and even as I teach you this, I want you to follow me clearly and attentively so that each and everything that I'll be explaining in this particular lesson, you will be able to understand them, you'll be able to know them and answer questions if they are to come even in an exam. The first thing that you need to know is a definition. What is the definition of a simple machine? What is this same thing we are calling simple machine? So you need to know the definition of a simple machine. You need to know what simple machine is. So if we are taught to say what is simple machine, what you need to know is that a simple machine is just a what? This is just a device. So I'll say this is a device that makes, this is a device that makes work done. It makes work done to be done. So it makes work done to be done in with easy. Let me say with easy. With what? With easy. This is what you need to know and understand. So a simple machine is a device that makes work done to be done with easy. Some people will tell you that a simple machine is a device that is used to overcome. So it is going to overcome a huge, so it is going to overcome a huge load by using, by what? By using small amount of effort. By using small amount of what? Small amount of effort. Small amount of effort. This is what you are supposed to know. This is what you need to get and understand. I believe you are able to follow through. You are able to understand all these things that I'm teaching you. So this is what you need to know on a simple machine. It's good to hear that people are connected from Mazabuka, Lusaka, different parts of the country. So now, what you are supposed to know is that, and even as we watch this video, don't forget to like. Don't forget to like this video. Don't forget to share this particular video. So I'm saying that a simple machine is a device that makes work done to be done with easy. The other one, the other definition that you can get is this one, where we are talking about overcoming a huge load by using small amount of what? Effort. This is what you need to know and understand. Today I am awake, connecting from Chirundu border. This is so good. This is so good that you're awake today. So this is what we need to know. This is what we need to get and understand. A machine is going to overcome a huge load by using small amount of effort. So even as we get to explain this, even as we get to talk about this, there are certain things that you are supposed to know. There are certain things that you need to understand. Some of the terms that we are going to be explaining, or some of the terms that I'm going to be mentioning here, will be something like mechanical advantage. This one, I'll be talking about this one. So these are things that you are supposed to know. What is mechanical advantage? So mechanical advantage of a simple machine. What is the mechanical advantage of a simple machine? after understanding what a machine is, you also need to know the mechanical advantage of a what? Of a simple machine. So this is the mechanical advantage of a what? Of a simple machine. How can you calculate now the mechanical advantage of a simple what? Of a simple machine? So what we get to do here, we are just going to say that mechanical advantage is equal to what? This is a ratio of what? Load over what? Effort. This is what you are supposed to know and understand. Mechanical advantage is it is just what? Load over what? Effort. This is what you are supposed to know and understand. So I always tell you that in physics, when you just know the formula, then you know the definition. Once you just get the formula that is being used, it means that even the definition, you know it, because you cannot know the formula without knowing the definition. Just the formula itself, this one, the formula itself, it is able to give you the definition of a mechanical advantage of a simple machine. So you say this is the what? This is the what? This is the ratio. I've told you this is the what? This is a ratio of the what? Ratio of the load. So ratio of the load to what? To the effort. Ratio of the load to the what? To the effort. This is what you are supposed to know and understand. Have you seen? So this is what you need to get. This is what you need to know. Don't forget to like the video, even as we get to watch this, even as we get to talk about simple machines. Don't forget to like the video. Don't forget to share it. So we are talking about the ratio of the load to the effort. And a particular formula that we get to use is this formula that we get to use. So this is a formula that you are supposed to know. I'm so good to see Learning Academy watching. Thank you so much. I see you, my brother. I see you, Learning Academy. I see you. Thank you so much for connecting. It's good to see you connecting. Thank you so much. So this is what we are supposed to know. This is what we need to get and understand. So this is the ratio of the load to what? To the effort. So these are some of the things that you need to know. These are some of the things that you need to get and understand. So you now need to know that the mechanical advantage is a term used to describe the amount of force that a mechanical device will utilize internally in order to perform the task for which it is designed for. This is what you need to know and understand. Good morning. Watching from watching within Kabwe. Good morning, and I'm watching from Kabronga, Rusaka. It's good to hear that people are connected. So let us see how we are going to make this very simple. My online students, I already told you we are supposed to be writing down these notes. It's just a continuation so that we can make our work easy. In the evening, we see other things that we can also cover. Aside this, you also need to know what velocity ratio is. You need to know what velocity ratio is. So velocity ratio should be known, which is what? VR, like this. Velocity ratio. Need to know what velocity ratio is. So you ask yourself, what is velocity ratio? So all these things I'm giving you, we are going to use them when we start calculating some problems here. So you need to make sure that you know these. You need to make sure that you understand what I'm explaining and what I'm talking about. This is what is the number of strings. Okay, this is so good. The number of strings. Who can try? What is velocity ratio? I want to see people trying. I want to see people trying. This is a lesson. It is an interactive lesson that we are having together. Somebody has commented to say that this is the number of strings. How about you? According to you, what is velocity ratio? Just according to you, what do you understand by velocity ratio? So now, velocity ratio, to cut it short and so that we get to move very fast, what you need to know and understand is that Velocity ratio. First of all, I will start by giving you the formula that you get to use. Velocity ratio is equal to distance. So we are talking about what? We are talking about distance moved by what? Distance moved by effort. So distance that is moved by effort. This is just the same as what? DE, like this. Then we say over what? Over the distance moved by what? Load. Over by distance moved by what? By load. So we say DL like this to make you understand. So this is a particular formula that you need to know and understand. So this is what? Velocity ratio, the ratio of distance, the load distance to load, you're saying effort distance to load distance. Okay, this is so good. Yeah, people get to know these things. Velocity ratio is distance moved by effort to the distance moved by load. Okay, yeah, so this is what I'm talking about. This same one. So we are saying that this is what? This is a distance. This is a distance moved. Distance moved by what? Distance moved by effort. So distance moved by effort. So you say this is the ratio. So you start with this. This is a what? It is also a ratio of the what? Ratio of the distance moved by effort to the what? To the distance moved by load. Distance moved by what? The distance that is moved by the what? By the load that is here. So this is what we are supposed to know. It's good to know that people already know these things that I'm sharing, or people already know these things that I'm teaching here. So we are just revising together. If things like this are to come in an exam, we won't even be able to face challenges. So I want you to follow me very well. I want you to get everything that I'll be saying. I want you to know this. So before we even go far, before we even get to revise through some important or good questions, there is something that I also want to discuss with you. I just want to deal with important parts, like we know that we've started intensive revisions. So even as I continue, those of you that could like to join my online lessons, this is my number. So this is the number that you get to contact. It's only 100 kwacha per subject. So those of you that could like to join us, those of you that could like to join my online lessons, this is the number that you need to contact. Even as you get to watch this, don't forget to like the video. Don't forget to share this particular video. So now, these are some of the things that you are supposed to know. This is something that you need to understand. So the next thing that I want us to look at is called what? Efficiency. So this is something that I also want us to look at before we even proceed, before we even continue and look at other parts. Efficiency. What is efficiency? So efficiency now, whenever we are talking about efficiency, what should come to your mind is something that is like this. So whenever we are talking about efficiency, you need to know that efficiency is just the ratio of the work output to the work input expressed in what? Percentage. So when you are told to say what is efficiency, we get to calculate efficiency by using the formula. You say this is what? This is work output. So you say work output over what? Work input. So work that is put in times what? 100%. Because this is a percentage. I've told you that the way we get to define this, once you know the definition, then everything becomes simple. So I've seen somebody, this is also another definition. This is so good. This is also another formula that we get. So the work output that we get to do. So to describe how well a device is able to work with a minimum energy that is wasted, you now need to know that for a simple machine, it can be expressed as mechanical advantage over velocity ratio multiplied by what? 100%. These are two formulas that you need to understand. Whenever we are talking about a machine, simple machine, this is what you need to know and understand. But there is also this one when you are given work. So you need to know that work is just the same as what? Energy, just one and the same. I believe you know that. So this is what you are supposed to know. This is what you need to understand. They are somehow similar. So these are some of the things that you are supposed to know. These are two formulas that you need to know and understand. So we get to calculate questions using these two formulas. You can use the formula that is there and the formula that is there. So I've already told you, if somebody tells you that what is efficiency, just the word efficiency, we are talking about simple machines. So you are going to tell the person that the simple machine is the what? Is the work output to the work that is what? Input expressed as a percentage. So the moment you just tell me that it is expressed as a percentage, what should come to my mind is that, okay, expressed as a percentage, meaning we are multiplying by what? We are multiplying by 100 because we want to find a percentage. This is what will come to my mind. So now, initially what you are supposed to know is that we have got 6 types of simple machines. So these are the ones that we are going to measure in so much. These are the machines that even come in your exams, 6 of them. So we are going to discuss through them. We are going to see how questions will come in those 6 types of simple machines. So let's just make sure that we follow through. Let's make sure that we get to understand this. So even as I lab here, let's make sure that we like the video. If you can share in 1 or 2 groups, we are in different groups. If we can share in 1 or 2 groups, I'll be very grateful. Share with your friends. You can share with a friend. Just share with a friend. So now, the machines that we are going to talk about, types of machines that I'm talking about. So types of what? Types of machines. So basically, we are going to talk about how many? 6 of them. We are going to talk about 6 types of what? Machines. So this is what we are going to look at. This is something that we are going to understand. So these are the ones that we are going to look at, the 6 types of machines. What are these now? What you need to understand, we've got what? Levers. You need to understand these levers. Here we've got what we call a pulley system. I think you know this. So we say pulleys. These are some of the machines that we are going to be talking about. So levers, we've got pulleys. You also need to have, we've got wheels. So we've got wheels, and this one gets to go with the axis. Like this. So these, they are just the same. So 1, 2, 3. You also get to talk about inclined plane. So all these are simple machines that we are going to look at. Inclined plane. All these are simple machines that we are going to look at. Inclined plane. From inclined plane, what do we have? We've got the screws. So screws and wedges. So these are some of the machines that we are going to talk about. These are some of the machines that we are going to know. Much familiar with pulley. So all these 1, 2, 3, 4, 5, even 6. So these are the ones that we are going to talk about. These are the ones that we need to know. That one is falling under this. Gears is falling under this. So what you need to understand about gears is falling under this. So those ones are major types of what? Simple machines. So the major types of simple machines are just 4. The ones that you are supposed to have. Major types. So the major types now are just 4 that you need to understand major what? Major types. The major types now. Number one, levers. So when we say levers, what we get to mean wheelbarrows, thrashers, all those shovels, all those things get to fall under this. The second one that you need to understand is a pulley. So you need to know a pulley. So a pulley, you need to know it. I think we are all familiar with this. We are all familiar with this. Even a wheelbarrow, sir, can fit in. So a wheelbarrow is falling under rivers here. This one that is here, levers. So, and pulley, aside pulley, we've got a gear. So we've got gears. Aside gears, the last one, we've got inclined plane. So inclined what? Inclined plane. These are the major types of what? Simple machines. How many are they? 4. 1, 2, 3, 4. These are the 4 major types of what? Inclined plane. I mean, major types of simple machines. And we are supposed to know these. If they are to come in an exam, we need to be able to answer questions. Have you seen? So, but these are, we can break down them so that we get to focus on these. Questions can come under these in an exam. From these 4 types, we can break them down and we make those sub machines that are falling under these to make them, we discuss through them. This is what I meant when I said we are going to talk about basically 6 types of machines. So now, the first one that we are going to talk about is called the levers. This is what we are going to start with. So this is something that I want us to start with. This is something that I want us to start with even as we proceed. So I want us to look at this. I want us to see how questions get to come whenever we are talking about this, how questions will come. So whenever we are talking about levers, so it depends with how you get to pronounce this, but all in all, we are talking about the same thing that is here. This is the same thing that we are talking about. So what you are supposed to know, this is just the same. It is somehow like this. Have you seen where you are given this? Under moment, remember moment. I think you remember moment. Where you've got, here we've got a load, let's say a load here. And then this side we've got effort that is being applied. So this is where we've got the what? This is where we've got the effort that is being applied. So you've got something that is like this. So this is just an example. This is to tell you that whenever we are talking about levels, what you are supposed to know and understand is that this is made up of a bar that turns on a fixed point called the pivot. So this is where we've got what? The pivot. You are just using small effort here to lift this. You discover that this load can maybe be 4,000. Maybe 4,000. Here maybe you're just using what? You're just using 1,000 what? 1,000 newtons. Have you seen what is happening? Just like this. So this is just an example of a simple machine of this nature or of this kind that you are supposed to know and understand. So these are some of the things that you are supposed to know. So whenever we are talking about this, all those spanners get to fall under this. You've got a spanner. A spanner is an example of this one. We've got a scissors. All those things that we get to use are just examples of levers, this same one. So some questions that we are going to discuss together will get to fall under this. You just need to understand this. So I can give you something like this. I tell you to calculate mechanical advantage. You are able to calculate the mechanical advantage. I can tell you to calculate velocity ratio, distance traveled by effort. You know that the distance from here, from the pivot to this effort, and from here to this load, you are able to calculate that distance. So this is something that you are familiar with. These are things that you already know. So make sure that you get this, make sure that you understand them. when we go to a pulley, when we are talking about a pulley, what you need to know and understand is that a pulley is a simple machine that is made up of a rope or a chain on a wheel around the rope fits. So a pulley gets to look like this. This is an example of a pulley. Discover that you've got something like this. You've got something that is like this here. Just a thing here. This is being pushed there. Then something that is like this. Then it goes down like that. So let me do this. So it goes down. Gets to go down. Let me do this. Okay. So from here it goes down like this. Then here, this is where you've got the what? The load. Then here, this is where you are applying what? Effort. You are putting this thing. Have you seen? So you are putting this thing. You are just putting it like this. This is what you are doing. So you are putting it like this. So this is being what? This is being moved. So effort, I put a T there. So this is what you are supposed to know. Just some of these things, you know them, you understand them. So this is how questions will be coming in your exams. You can just find a question like this. Tell you to calculate mechanical advantage. Tell you to calculate velocity ratio. So these are common things that you are supposed to know. These are the common things that you need to know and understand. So a pulley is something that is just like this. This is what you are supposed to know. This is what you need to understand. When we go to the other one, when we go to this one, which is the wheel and what? Axle. So when we go to this one, you now discover that a wheel, something like this, let's say it is something like this, then this gets to move out like this. You get to have something that looks like this. So this is just an example. Have you seen the way it is? Just like this. This is just an example. So the wheel and the axle is a simple machine. Is a simple machine that is containing a large wheel fixed to a smaller wheel and a rope in it, like this. So this is something that you are supposed to know. It is something like this. Though I'm not good at drawing, but I think you are able to see this is how this one is. So the common handle is mainly made of the what? Mainly made of this thing we are calling a wheel. So this is just a wheel like this. Then we've put something there, a load. Have you seen? This is what is happening. So you are able to move this. If this is big, you are able to move it like that. You are able to move it like that. I will join in later. Let me get some sleep. Okay, so this is what we get to see. These are some of the things that we get to know and understand. So even as we get to advance, we are going to be looking at some of these things. We are going to know some of these things. So let's make sure that we know this. Let's make sure that we get to understand some of these things. So under the ratios, under this same wheel, what you are supposed to know that the velocity ratio of the wheel and the axle is given by this formula. Let's say if you are told to find the velocity ratio, you need just to say that the radius, we say radius of the what? Radius of the wheel. This is what you need to know. Radius of the wheel over the what? Over the radius. So the radius of the wheel from here to there. This is the radius. So radius of the wheel and the radius of the what? Axle. This is what you are supposed to know and understand. So these are some of the things that you are supposed to know. So this thing, this is the what? This is the wheel that we are talking about. This one, this is the axle that I'm meaning like this. So have you seen? So for us to find the velocity ratio, you get the radius of this thing that is inside here and the radius of this wheel. So we get to use this particular formula. So these are some of the important formulas that you are supposed to know. So when I just say, okay, the formula we are going to use is this, at least you know where it is coming from. You need to know that. And what if you are taught to calculate the mechanical advantage? So the mechanical advantage, let me do this. So I don't know if there is someone that knows the mechanical advantage of this, if you are taught to calculate the mechanical advantage of that one. So the way we get to calculate this, we are now talking about what? We are now talking about the same what? Same formula. This same one can also be used as what? Mechanical advantage. This is what you are supposed to know. This is what you need to understand. So we just get to use the same formula. So this, the radius of the wheel can be said radius of the wheel over the radius of the what? Axle, like this. So it is just one and the same thing. This is what we are supposed to know. These are some of the things that we need to get and understand. Aside this now, there is also something that we get to talk about, which is the inclined plane. You need to know something about the inclined plane. You need to know how those things get to work. The inclined plane. So you need to know the inclined plane. So I just want you to know this. We now consider the what? Inclined plane. You need to know this. So these are simple things. When you've got something like this is what we mean by an inclined plane. We've got something that is like this. You are putting this thing, moving from this point to that point like this. This is how it is what? Moving. So when you are moving, when you are putting this, you now discover that this part that is here, this is where effort is. You are using what? You are using effort. And from here, there is this length. From here to there, this is the length that is here. This is length. Then this one that is here, the distance that is there, this is what we are calling the what? This is what we are calling the height. From where this thing is coming from to where it is going. Have you seen the way it is like this? So these are some of the questions that get to come. We are able to know some of two things here. So you need to know what is velocity ratio. How can you calculate mechanical advantage on an inclined plane? You need to know all those things. So the way we get to calculate the velocity ratio of the inclined plane, you just say the length, you say this is just the length. So the length here, I mean, is the height. So let me do this. We just get this height that is here, the same height that is here. You divide it by the what? So we say, okay, we're going to say that the length here, the length that is here, you get this length that is here. Okay, let me try to, okay, which one is which? So velocity ratio, we get the length here. This is the length that we get to get. We get this. So we get length. I'm just going to do this. You know the length there. Over what? Over the height. This is what you are supposed to know. So if you want to calculate velocity ratio, this is what we get to use. Here we don't use load, sir. No, here we are going to use it when we are talking about what? When you get to use effort. So whenever you are talking about effort or loads, whenever you've got these two, that's when you get to apply them. But in this case, have you seen, we are talking about distance. So even the formulas, we are supposed to look at what? Distance. So it is the distance. So you get to use them according to what you are given. If you are given using, what about load? Here we don't have any load. Have you seen? The load is this one. Then this is the effort that is here. I forgot a T. This is the effort. So this is a particular formula that we are going to use. This is a formula that we are supposed to use. So we know mechanical advantage. I've already given you the formula in terms of load and effort. But these ones I've not given them. I'm giving you now so that you know them. In case you are not given these two, you can calculate what? You can calculate using length. So, sir, does that formula mean efficiency of the wheel and the axle is 100% when it is due? So, when it is, so this is what it means. So, if the wheel and the axle is due, it means that its mechanical advantage can be calculated by those formulas that I gave you. So, this is what we are supposed to know and understand. So mechanical advantage in terms of length, what you are supposed to do is you just say, okay, it is the what? Length over what? Height. Same formulas, length over what? Height. You know where the height is according to this. You know where the height is. You know where the what? The length is. So don't say, okay, height over length, then I give you a question, then we call this as height, then you try to confuse things. You know that the height should be here. You need to know that we get this one that is here, and this is the length that is there. Meaning, if you are given this and that, you are able to calculate that using Pythagoras theorem. So the way this gets to apply is that you get to apply the knowledge that you already know to answer certain questions in an exam. So if you're watching this, don't forget to like this particular video. Don't forget to like it. So these are the formulas that we get to use. Have you seen? So we say length over height. Length is L over height, which is H. This is length. We get to look at length over what? H, which is the height. These are the formulas that we get to use. So this is what you need to know. This is what you need to get and understand. A question can come in all the different ways that we've talked about. A question can come in all angles. So you just need to know all these are ways in which questions get to come in an exam. These are just some of the things that you are supposed to know. We are going to calculate some questions here, and these are the same formulas. So you are not even supposed to wonder why. If I say, okay, velocity ratio, we just get this over that, you already know, okay, this is a particular formula that, and these are the same. Have you seen the way we are calculating them like this are almost the same? Using same what? We are just using same formulas to calculate them. So this is what you are supposed, when we go to screws. So let's say when we go to screws. So we don't know how questions will come in an exam. That is why I'm giving you important things that you are supposed to know, important parts that you need to get and understand, so that if they are to come in an exam, you will be able to handle them, you will be able to explain them. So now when we go to a screws, let's say this is a screws, something like this, it is like this. So let's say it is going, this is how it is, like this. Let me try to something like this. So something like this, a nail. Have you seen? So the way it is, this is a screw now, something like a nail. So it's called that we've got these things that get to be like this. These things, when it goes this side, comes this side, goes like this. We've got some of these things. Have you seen? We've got something that is like that. So what you are supposed to know and understand, under this, there are some parts that you need to know here. So here we are talking about this. Have you seen where this is? So you can talk of the diameter here. This is the diameter that is here. This is the diameter. Then the difference between these two, from here to there, these differences are the same, just that I haven't written this very well. But these are the same. If you've got a screw, you're able to agree with me that these things that get to move like this, like this, are the same. Just that I didn't put this one very well. So let me do it like this so that we are able to understand. They are just the same like this. They are just the what? They are just the same. These are just the same. I think you are able to agree with me. A screw, these lines that get to be like this are just the same. Have you seen? Just that right now I don't have a screw. I would have given it as a practical example. So this one is a diameter, the way it is like that. That is a what? A diameter from here to there. But the distance from here to there, this distance from here to there, this is equal distance from here to there. This is what I'm calling as what? Pitch. This is what I'm calling as pitch. So this is the diameter. This one that is here, have you seen? This is the diameter. Let me say, this is the what? This is the diameter. Then this small distance here, this is what we are calling what? Pitch. So this is what you are supposed to know. So how can you calculate the mechanical advantage and how can you calculate the velocity ratio? You never find questions like this, but it's very important to know them in case they come. You say circumference, you find the circumference. So you find the circumference of the same screw over the what? Over the pitch. This is what you are going to do. Then if you are told to find the mechanical advantage, you just say circumference, the same one. So how do you find circumference? Maybe there's someone who doesn't know how to find the circumference. So we get to use same formulas here. Circumference of the same screw, you say pi what? Pi d. You get pi times diameter over what? Over the pitch, which is length, like this. So this is how you find the circumference. You get pi. Pi is a constant. You find the diameter, the distance from there to there, over length. So this is this. These are same formulas for velocity ratio, mechanical advantage like this. We get to use same what? Same formulas. So these are some of the things that you are supposed to know. These are important parts that you need to get and understand even in an exam. So I'm just giving you formulas here. We are just discussing formulas. We are just discussing formulas here. You need to understand some of these things that we are talking about. So you just need to know all these. You just need to know all these things that we are talking about. So this is where we are going to end from. So when we the next time when we meet, we are going to continue with this. So those of you under my online lessons, when we meet for physics, it's just a continuation from here. So this is where we are going to end from. I think I've given you some formulas, some basic information that you are supposed to know. So the next thing that is remaining is just looking at how questions get to come, how you get to calculate some questions even in an exam. So if you're watching this, don't forget to like the video. Don't forget to even share it. This is where we are going to end from. I believe you were able to write down these things here. You were able to write down these things that are here. So we end here. Thank you so much for watching. We continue tomorrow with mathematics.